Hello friends, in this particular video we will learn the voltage series negative feedback amplifier. As far as this particular topology is concerned, we have learned rather lots of topologies, 4 topologies we have learned depending on the sampling and the mixing part of the negative feedback amplifiers. And this is the first voltage series negative feedback topology that we have to learn, that we have to analyze, that in that we have to find out what will be the voltage gain with feedback, what will be the input resistance with feedback and the output resistance with feedback. Now on your screen, voltage series negative feedback amplifier which has been given. Now once we get the name as voltage series, now with that namakaran we will be getting that voltage term indicates that its sampling process is voltage, sampling parameter is voltage, and this is been done by the shunt sampling, right? So voltage sampling is associated with the shunt circuit, and this series word represents that the mixing is of the type series. So the circuit at the input side is series mixing. Okay, so I will draw the particular circuit where I will be having voltage at the output side and I'm adding the series representation at the mixing circuit. So whenever I'm dealing with the series connection at the mixing part, obviously I have to deal with the voltage mixing. So basically here at the output side I have the voltage parameter, as well as at the input side I have voltage parameter only. So I can say that if I have output parameter is voltage, input parameter is also voltage, then whatever forward amplifier I will have to use is nothing but voltage amplifier, right? So I will draw this particular voltage series negative feedback configuration, then we'll get to know that how this is been achieved to have the name as voltage series negative feedback amplifier. This is the configuration where we'll have to learn that whatever voltage amplifier I'm saying is nothing but the forward amplifier, where we generally say it as with gain A, right? So I can say that this can be represented with the box of A, right? And this is been represented with the box of B, where B is nothing but the feedback gain, right? So it is also called as the feedback factor. So VF divided by VO, it represents that it's nothing but the output ratio of output of voltage divided by the input of this particular box is nothing but VO, because voltage itself is been fed back to your feedback circuit, and after this feedback circuit it has been added, or I can say mixed up with your input circuit with in series combination. That's why this is voltage amplifier, this is voltage sampling, I can say. So we will note this as it's a voltage sampling, right? And obviously this part is nothing but series mixing. Okay, so whatever voltage Vi and Vf that I'm getting, it's nothing but the series mixing. So that's why इसका नामकरण क्या आया है, voltage series negative feedback. So this is how our configuration general circuit diagram will look like this, right? Now from this particular circuit diagram we have to learn that how can we achieve to get the voltage gain, how can we achieve to get the input impedance, how can we achieve to get the output impedance with feedback, right? If feedback is not present, right now assume that this B box is not present. That means VF is equal to 0. I don't have VO which is coming into this particular B part because B part is not available. So this becomes your open loop circuit. So this is called as without feedback circuit, right? So circuit without feedback will become free of this particular box B, right? So I can say that whatever VO I'm getting, that is nothing but AV into VI, isn't it? This particular VO is nothing but the AV into VI. This is because whatever RO I'm getting, as we have learned in voltage amplifier, that RO is very less valued resistance, right? So I can neglect that part, right? So we'll say that AV VI is equal to VO, right? Now I can say that this VI itself will act as a VS because VF is not present, VF will be 0. So I can say that AV VI is equal to VO, AV is equal to VO divided by VI, and that is called as open loop gain. Okay, so here I will say that it's nothing but open loop gain. इसको और एक नामकरण है, this is also called as the gain without feedback. Okay, so I will take this term as gain without feedback. Okay, this term is important when we are solve the numerical, right? Right now we are dealing with feedback circuit, right? So this is just the representation to have the knowledge about what is your open loop gain, what is your gain without feedback, right? So that is nothing but AV in case of voltage amplifier, in case of voltage series negative feedback circuit. Now let's come to the particular part of the analysis. Okay, voltage gain of voltage series negative feedback circuit. Simple. Now let us understand the fact that I want to find out voltage gain. So we will say that voltage gain will become, it's nothing but AVF. This AVF is nothing but F indicates with feedback. F indicates what? F indicates with feedback. So if feedback is present, whatever gain I will be getting, I will name this as AVF, and I will say mathematically AVF is equal to VO divided by VS, and that I want to calculate. Okay? Let's start with the analysis. See to it that whenever I am saying I have to use the voltage sampling and series mixing. So series mixing is possible only when two voltages are added with feedback and input, and that will become your source voltage, right? So we'll say that whatever value I'm getting, Vs is equal to Vi plus Vf. Okay, Vs is equal to Vi plus Vf, that is true, but I know that, we'll say but, take this equation number 1, but know that what is Vf? From this particular formula, from this particular analysis, will get this formula will get to know that what is Vf? Vf is nothing but beta into Vo, right? So Vf is equal to beta into Vo. And what is the value of Vi? I know that what is the value of Vo? Vo is nothing but Av into Vi, right? So what is the value of Vi? Vi is nothing but Vo divided by Av. So we can also say that Vi becomes Vo divided by Av. Okay, fine. So we have got the two formulas. Vf is equal to B into Vo and Vi is equal to Vo divided by Av. Basically, I don't want Vi and Vf. I want the ratio of the form Vo and Vs. That's why I'm doing this particular conversion of Vf and Vi in the form of Vo. So let's try to get what will be the value of Vs now. Vs will become, I can take this VO outside and let's see what value we'll be getting. That value will become 1 plus AV into B divided by AV. Yes, so whatever we have got is in the form of Vs is equal to Vo multiplied by some constant value, some parameter in the form of gain parameter, right? So let us try to get that particular voltage gain in the last step. I can say that Vo upon Vs will become AV divided by 1 plus AV into B, and this is your last formula for voltage gain with feedback. So I can say that this particular formula is for voltage gain with feedback, whereas AV is nothing but open loop gain, or I can say gain without feedback. So if you analyze this particular thing, gain without feedback is greater than that of gain with feedback. That is the effect of the negative feedback amplifier, isn't it? So this first thing we have done, and now we will move towards the second thing, right? That is nothing but input impedance. Input impedance with feedback. Okay, so whenever we are learning for input impedance with feedback, keep this in mind that whatever we have learned so far, Ri is nothing but input impedance only, but that Ri is input impedance without feedback. If feedback is not present, then whatever resistance, input resistance I will be getting, that is nothing but the series combination of Rs and Ri. But as I already know that in voltage amplifier, Rs is very low as compared to Ri, so your input impedance is itself Ri, right? And your input impedance with feedback that we have to find out. So we will do some analysis based on the input impedance without feedback, right? So input impedance without feedback is Ri is equal to Vi divided by Ii. Okay, we'll say that this is equation number 1. Okay, let's try to get the previous form, that is Vs is equal to Vi plus Vf. Clear? Very good. What is the value of Vi? I want the value of Rif, that is nothing but your resistance with feedback. Okay, this is nothing but the input impedance without feedback, right? So Vi I will convert it into resistance, so that will become Ii into Ri. What's the value of Vf? Vf is nothing but B into Vo. So I will write it here first, B into Vo. But what is Vo? Vo is nothing but AV into Vi. And as we have learned that Vi is equal to again Ii into Ri. So the next step I can say that I will take Ii Ri plus B into AV into Vi is nothing but Ii into Ri. So I can take this Ri common, right? I will take this particular parameters common, and I can say that this will become Ii into 1 plus AV into B into Ri, right? Now question arises, what is exactly the value Vs, right? So we will keep this Vs as it is here, and in the next step we will try to get that what is the exact value of Vs. See this particular diagram. This particular circuit tells you that whatever Ii is flowing through Rs and Ri, that will be same when we are considering the value of the resistance with feedback as well as without feedback. So your current value is same as it is nothing but the series combination. Okay, so I can say that whatever the resistance with feedback I'm getting, that is Rif, is nothing but the ratio of Vs divided by Ii. Okay, so I will first write that particular formula. I can say it is nothing but Rif is equal to Vs divided by Ii. right? So I can say that what's the value of Vs then? Vs is equal to II into RIF, right? And whatever Vs ka value we have got right now, we will put it in the formula, that is Vs is equal to II into that stuff 1 plus AV into B multiplied by Ri. So let's try to get what the value of RIF I'm getting. We can say that Vs will rewrite this particular equation Ri 1 plus AV into B, right? And I can say Vs is nothing but II into RIF is equal to Ri 1 plus AV into B. Obviously II is present, right? Now if you note that from this particular equation II ne II ko maar diya, and I will be getting that RIF, that is input resistance with feedback, is same as Ri, but multiplication with a factor of 1 plus AV into B. So here I can conclude that whatever formula I am getting, right, this particular formula is for input impedance with feedback. So this formula represents input impedance with feedback, okay, and that is represented by RIF. So this second part we have done. Now we'll have to learn the third and important part of this particular analysis, that is output impedance with feedback. Output impedance with feedback that we have to analyze. Now for that, very important aspect that we have to consider, that connect Vx at output as source. We have to connect external supply as Vx at exactly at the output side, that means taking this load out, and we can say that we'll connect this Vx, right? So the current flowing through that particular power supply directly is nothing but your value of Ix, okay? So output as source and short the input voltage supply. So basically what I'm trying to deal, I'm closing your input side and I want to look at the output side. So I will connect the power supply at the output side with the name Vx, arbitrary name. You can say that name Vy, Vz, anything, right? So I'm saying it's nothing but Vx, and the current flowing through that particular power supply is Ix. So ultimately it's nothing but same as whenever we are looking from the output side, whatever resistance I'm getting, that is nothing but your output resistance with feedback, okay? So these two things are very important as far as this output impedance with feedback is considered. Connect Vx at the output side and short the input voltage supply. If it is voltage supply, then you have to short. If it is current supply, then you have to open it up, because if we are replacing this power supply with their respective internal resistances, right? So what we will do the pictorial representation, not exactly circuit diagram I'm drawing. Here A is equal to VO divided by VI. Here we are getting the VI and they are connected in series, okay? This is nothing but B. B is nothing but VF divided by VO, clear? And then here I am saying this is your resistance RO, okay? And this is the resistance RL that we are getting, okay? From here, same voltage VO we have to connect at the input side of the feedback, right? This is the connection, and important thing that we have to consider as short circuit your input side, okay? I have to connect this particular Vx. So these two important part that we have to consider, this is nothing but Vx. So we have to keep this in mind, that we have to connect this Vx, external power supply Vx, and second thing is we have to short the input source. So by shorting this input source, we'll get one mathematical equation that whatever Vi I'm getting, that is same as Vf as far as magnitude is concerned. Okay, hold on, this is the value of RL. Okay, if we have to get this particular KVL, then and only then we'll move further for the calculation of this particular ROF. Okay, before that we will say that output impedance without feedback is equal to RO is equal to VO divided by IO. But I know that what is the value of VO? Instead of VO, I will connect the external power supply, that is Vx. So I can say that it's nothing but Vx divided by IO. Okay, so we have to reach with this particular value to find out the value of ROF. Okay, so now what we will do, we will say this is nothing but your input KVL. Okay, we'll name this as loop A. So in this loop A, inside this particular box, I have the voltage source as AV into VI. Got it? AV into VI is one source. This voltage drop is nothing but IO into RO, and this is nothing but the value Vx. Okay, so I can say that I will redraw this particular circuit over here such that it will get a clear idea about it. This will be your resistance RO. This is your voltage source AV into VI, and this is your load resistance, and here I will be having Vx. Okay, so I can say that whatever value I will consider for KVL, that should be only with Vx, IO, RO, AV and VI. Okay, so what I'm saying that this voltage drop plus this voltage drop plus this voltage drop is equal to 0, right? So what we will do, apply KVL to loop A, right? We have given the Namakaran as loop A. So we can say that this is plus, this is minus, this is plus, this is minus, and this is plus, this is minus. Okay, so we will start our equation as Vx, okay, minus IO into RO, yeah, minus AV into VI is equal to 0, right? I don't want the value of VI, right? Here I can say that, but as Vs is equal to 0, I can say that Vi is equal to minus of Vf, right? And what is Vf? Vf is nothing but B into Vo, right? So I can say that what is Vf? Vf is equal to B into Vo. So minus Vf will become minus B into Vo. But what is Vo? Vo is nothing but Vx, right? So I can say that here it will be minus B into Vx, right? What we will do, we will put this particular value in this equation. Okay, so we'll get to know that what's the value of this particular equation, Vx minus IO into RO, minus of minus will become plus, AV into B into Vx is equal to 0, right? Very simple. I will keep this I minus IORO at the right hand side. We will get to know that Vx will become same. I'll take it common, and Vx in bracket 1 plus AV into B, right, will become equal to IO into RO. Now I can say that Vx divided by IO is equal to RO divided by 1 plus AV into B. This is your formula for output resistance with feedback. because Vx is nothing but VO. VO divided by IO is nothing but your output resistance with feedback. So I can say that this is nothing but ROF, and I will name this as output resistance or output impedance. This will become output impedance with feedback. Okay, so far we have learned that in a voltage series negative feedback amplifier, whatever conclusion I have made as, let's make a conclusion, voltage series negative feedback amplifier. Okay, here I will say gain. Okay, here it will be, say, parameter. Here it will be without feedback, and here it will be with feedback. Okay, we'll make a chart, a simple chart, where I can say that first parameter will become gain. Gain without feedback is nothing but AV, right? With feedback is nothing but AV divided by 1 plus AV into B. Okay. Second is input impedance. As far as input impedance is considered, it's nothing but Ri without feedback. With feedback, I will be getting as Ri into 1 plus AV into B. It means that input impedance increases, right? Gain factor decreases, right? Let's see what about your output impedance. As far as output impedance is considered, we have got that without feedback it's nothing but RO, and with feedback we have got that RO divided by 1 plus AV into B. So as far as the voltage series negative feedback is considered, your input impedance increases, output impedance decreases, and your gain factor decreases with feedback. So this is the effect when we considered voltage series negative feedback amplifier. Okay, so in the next video we will learn few topologies with the same analysis but different amplifiers. So stay tuned for that. Learn more and more ADC along with me, along with Ekeeda videos. Thank you so much.